Welcome everyone. I am absolutely thrilled you're joining me for this explainer. Today we're diving into the absolute magic of physics. And hey, I'm not talking about pulling rabbits out of hats, right? We're talking about the actual, tangible, completely awe-inspiring rules that govern our entire universe. From the way you're sitting in your chair right this very second to the most distant stars out in the galaxy, physics is the invisible hand guiding the whole shebang. So get ready, because we are about to solve some truly mind-blowing mysteries together.
To kick things off, I've got a classic question for you. Which is heavier, a ton of bricks or a ton of feathers? Now, your brain is probably instantly screaming, the bricks, obviously, because, well, we associate bricks with being super heavy and feathers with being incredibly light, right? It's a fun little trick that totally disrupts what we think we know about everyday science.
Okay, let's dive into this because the answer is actually neither. They both weigh exactly 1 ton. Their masses are completely identical. The big difference here comes down to a really fascinating concept called density. Because feathers have an incredibly low density compared to thick, heavy bricks, a ton of feathers is going to make a massively larger pile than a ton of bricks. It's the exact same weight, just taking up a drastically different amount of physical space.
So here's the roadmap for our scientific detective work today. We're going to start with the magic of physics, then explore forces, motion, and gravity. After that, we'll look at the 6 simple machines, uncover the secrets of light and sound, and finally, we'll blast off into some mind-bending space physics. All right, let's jump straight into part 1, the magic of physics and understanding the rules of the universe.
So what exactly is physics? I really don't want you to think of it as just a boring list of equations on a dusty chalkboard. Physics is the study of matter, energy, motion, and force. It's basically the ultimate toolkit for understanding why things do what they do. I mean, it solves everyday mysteries. Like, did you know that the simple act of just walking down the street relies entirely on physics? It's the friction between your shoes and the ground, paired with an equal and opposite reaction, that actually propels you forward. Or think about your microwave. It doesn't use magic to heat up your leftover pizza. It uses a specific frequency of microwaves to excite the water molecules in your food, creating heat through a really cool process called dielectric heating. That is literally physics in action, right in your kitchen.
Moving right along to part 2, forces, motion, and gravity. These are the invisible pulls that shape our everyday reality.
Let's move to and see how this builds by looking at Isaac Newton's famous 3 laws of motion. And we're going to use the perfect chronological example for this, a mini rocket launch. So first, the rocket is just sitting there on the launch pad. It remains completely motionless unless a force acts on it. That's Newton's first law, inertia. Second, when you do launch it, its acceleration is heavily affected by its mass. A really heavy rocket needs way more force to get moving than a tiny, light one. Makes sense, right? That's the second law. Finally, the third law. The gas blasting forcefully downwards creates an equal and opposite reaction, which powerfully propels that rocket straight up into the sky.
Now, we've got to bust a pretty major historical myth here. The ancient philosopher Aristotle believed that heavy objects naturally fall faster than light ones. And honestly, it kind of makes intuitive sense, doesn't it? But Galileo realized that the only reason a feather falls slower than a hammer here on Earth is simply because of air resistance. If you remove the air, they fall at the exact same rate. And incredibly, during the Apollo 15 mission, Commander David Scott actually proved Galileo right. He stood on the moon, where there's absolutely no air resistance, dropped a heavy hammer and a light falcon feather at the exact same time, and they hit the lunar dust at the exact same fraction of a second. How cool is that?
And of course, that brings us to gravity, which is simply an attraction based on mass. Earth pulls down on us. But if you were to somehow step foot on Mars tomorrow, where the mass is totally different, a 200-pound person would suddenly weigh only 76 pounds. Out in the deep vacuum of space, there is zero gravity, meaning astronauts are never at rest. They constantly float around. But hey, gravity isn't undefeated right here, on Earth either. Water can actually defy gravity by moving upwards through narrow plant stems or tiny tubes in a pretty wild process known as capillary action.
Okay, let's head into section 3, 6 simple machines and how humans manipulate the rules.
And this brilliantly illustrates something I find so fascinating. Look at all the complex machines around us: cars, bicycles, towering cranes, even the flush mechanism on your toilet. They might look incredibly complicated on the surface, but they are really just clever combinations of 6 ancient, simple machines that multiply our force and basically manipulate physics to our absolute advantage.
So let's rapidly run through these foundational 6. First up, the inclined plane. It's just a simple ramp that makes lifting heavy loads vastly easier. Second, the wedge. Think of an axe used for splitting things apart.
Third is the screw, which is actually a secret. It's just an inclined plane wrapped really tightly around a cylinder. Number 4, the lever. A baseball bat, a crowbar, or even the seesaw you played on as a kid, those are all levers turning on a pivot point. Fifth is the wheel and axle, which enables everything from skateboards to huge semi-trucks and even Ferris wheels to move smoothly. And finally, the pulley, a grooved wheel with a rope that lets you use your own body weight to hoist a flag or raise a massive boat sail. Literally everything we build starts right here with these 6.
Up next is Section 4, Secrets of Light and Sound, Perceiving the Invisible Waves.
Now, what's really interesting about this is the staggering difference in speed. Light is the undisputed speed champion of the universe, blasting through empty space at roughly 186,000 miles per second. Sound, on the other hand, it's a bit of a slowpoke. It trudges along at a sluggish 1,125 feet per second. This is exactly why you always see the bright crack of lightning across the sky well before you actually hear the rumble of the thunder.
Because light travels at that absolute staggering, almost incomprehensible speed of 186,000 miles per second, it takes exactly 1.255 seconds for light to travel all the way from the Earth to the Moon. Just think about that. Just over 1 single second to cross that massive, empty, cosmic void. Our human perception of these waves is endlessly fascinating too. For instance, you know the sunlight warming your face right now? Sure, it took about 8 minutes to travel from the sun's surface to Earth, but that specific light was actually created deep inside the sun's core tens of thousands of years ago. Next up, because sound requires a medium, like air or water, to vibrate, space is completely and totally silent. Yup, all those Hollywood sci-fi explosions are a total lie. Then there's the Umpemba effect, this bizarre physics phenomenon where under the right conditions, hot water can actually freeze faster than cold water. Wild, right? And finally, light perception totally varies by species. We get to see a vibrant, beautiful rainbow, but dogs view the world mostly in dull yellows, blues, and grays.
We've finally arrived at Section 5, Mind-Bending Space Physics. This is where common sense totally falls apart.
The cosmos is just incredibly wild. While Earth spins like a top, Uranus rolls on its side like a giant cosmic barrel. Venus spins in the exact opposite direction to Earth, meaning the sun actually rises in the west over there. And density in space, it is terrifying. Get this, if you scooped up just a single teaspoon of material from a neutron star, it would weigh 6 billion tons. That is significantly heavier than Mount Everest, all in one tiny teaspoon. Oh, and physicists mathematically describe certain complex black holes as being hairy, which is just a funny way of referring to their external parameters. But perhaps the most mind-bending concept of all is time dilation, born from Einstein's theory of relativity. It states that time isn't actually constant. The faster you travel through space, the slower you experience time compared to someone who is just standing still. So the crucial point is, this isn't just theoretical math happening on a whiteboard. Your phone's GPS navigation relies heavily on satellites zipping around the Earth. Because they're moving so fast, time actually ticks slightly slower for them. If physicists didn't program your GPS to adjust for this exact time dilation, your map tracking would be off by several kilometers every single day. You'd literally be lost without Einstein.
And that leaves us with a final truly beautiful thought. Because light takes time to travel through the sheer vastness of space, whenever you look up at the night sky, you aren't seeing the stars as they are right now. You're seeing them exactly as they were thousands or even millions of years ago. Stargazing is quite literally a form of time travel. It really makes you wonder, as we uncover the magic of physics all around us, what other ghosts from the past are we looking at right now without even realizing it? Keep looking up, keep asking questions, and I really hope this explainer sparked your curiosity to go out and explore the incredible physics happening all around you every single day.